Hey guys, today we'll be talking about multiplication properties and specifically the product of powers. And there are several rules that you need to know for this section. So let's get started. Okay, so your first example, we have 12 to the third times 12 to the fourth. But when you raise something to an exponent, what does that really look like? Well, 12 to the third, you know that that's just 12 multiplied 12 by 12 3 times. So in reality, it looks like this. 12 times 12 times 12. Okay, but what about 12 to the fourth? Well, let's look at it. Okay, 12 to the fourth would just be 12 multiplied by itself 4 times. Okay, so if you have all those 12s, that really means that you have 12 multiplied by itself 1, 2, 3, 4, 5, 6, 7 times. Okay, so if you wanted to put this in exponential form, that would give you 12 to the 7th. Okay, but what do you notice? Okay, if you look at your exponents, we have 3, we have 4, and we have 7. Okay, what do you notice? Keep that in mind. Okay, let's look at this one. Okay, we got j to the fourth times j squared. Well, j to the fourth just means j times j times j times j. And j squared means just j times j. Okay, so just like last time, we have 1, 2, 3, 4, 5, 6 j's. So we have j to the sixth. And once again, look at your exponents. You have a 4, you have a 2, and you have a 6. What's the pattern that you're seeing? Okay, the pattern that you're seeing is that when you have bases that are the same and you have exponents and they're multiplied together, you can add the exponents. Okay? 4 plus 2 gives you 6. And 3 plus 4 gives you 7. So that's where we're getting those solutions. Okay, so for your summary for this rule, I want you to write the following. To multiply powers, with the same base, keep the same base, and add the exponents. Okay, so to multiply powers with the same base, keep the same base, and add the exponents. Okay, now mathematically speaking, it would look like this. If you had a to the m plus a to the n, or multiplied by a to the n, I'm sorry. Okay, so a to the m multiplied by a to the n. To put those together, you would do a to the m plus n. So you want to add your exponents when they have the same base. Okay, so make sure you have all this written down. We'll try a few quick examples. Okay, now on these, I want you to look at these 4 problems, and I want to see which ones you can simplify, which ones would work out for us. Okay, now if you did this, then you see on the first one, you have r to the 18th times r to the 3rd. They have the same base. They're multiplied together, so we can add the exponents. R to the 21st. Okay, what about number 2? Okay, are they multiplied together? Yes. Do they have the same base? No, so we cannot simplify this one any further. Okay, what about number 3? We have the same base, but they are not multiplied together. Okay, so we cannot use this property. Okay, and the last one. And this one, we have the same base. They are multiplied together, so we can add the exponents. And 512 plus 6 is h to the 518th. Okay, so here's just a few examples that are going to get us started. And on the back side of this page, we will try a few more. Okay, but before we get started, I got a quick joke for you. All right, here's the joke. Did you hear about the shampoo shortage in Jamaica? It's dreadful. You like it. Okay, so we're going to go through a few of the problems that are a little bit more tricky. Okay, but they're a little bit long, but they're not that hard. Okay, you just got to take it piece by piece. And I'm going to use individual colors to make this a little bit more simple for us. Okay, so we're looking for the same coefficient or the same base, and then we'll take it from there. So we have our f's here. Okay, so let's find our f's. Okay, we know these are multiplied, and they're the same base, so we can add them together so that 4 plus 6 gives us f to the 10th. Okay, let's look for our h's, and we'll do them in red. Okay, so they're the same base, they're multiplied together. Then we take 7 plus negative 3, and that would give us h to the 4th. Okay, the last one is your w's. Okay, so we'll circle our w's in blue. Okay, and since they're the same base and you can multiply them together, 2 plus 5 for the w's gives us 7, so we have w to the 7th. Okay, so that is our final solution for that one. Okay, let's try another one. Okay, so once again we're going to use our black first, so we'll circle our d's here. And since we have the same base and they're multiplied together, we can take 7 plus 3, which is 10, so we have d to the 10th. And we'll use red for the s's. So we have negative 4 and 11 for the s's. Negative 4 plus 11 is 7, so we have s to the 7th. And then lastly, all you have left is your y to the 9th, so that we can tack that on the end. Okay, so you should get the hang of these pretty quick. They're not too bad at all. Okay, but sometimes you have examples that have numbers in front of the coefficients, and when that happens, you have to handle it a little bit differently. When you have that type, if they have the same base and they are multiplied together, you simply have to multiply their coefficients. Okay, so 7 times 4 is 28. And then we have to add our exponents like we've been doing. So 8 plus 12 is 20, so we have 28x to the 20. All right, let's try a few more. Okay, look at example number 4 real quick. Okay, so on this one we have two j's and they both have a coefficient, so we will need to multiply our coefficients. So take 18 times 11 on your calculator, and if you multiply that together, that would give you 198j. Okay, but remember, we have to go ahead and add our coefficient or our exponents. So we have 7 and negative 1 for our j's. So 7 plus negative 1 would give us a j of 6 for our exponent. Okay, so go ahead and circle our j's. Keep doing the same thing that we've been doing. And lastly, we have our k's. Our k's both have a coefficient of 1, so we don't need to worry about that. Okay, so let's circle our k's in red here. So since they have the same base and they're multiplied together, we can add the exponents. So negative 5 plus 62, if you put that in your calculator, would give you k to the 57. So your final solution, 198j to the 6th, k to the 57. All right, let's try one more, and we'll be done. We'll do example number 5. Okay, so remember you have to multiply coefficients that have the same base. Okay, so we have 8m and 7m. Well, 8 times 7 is of course going to give us 56, so we have 56 m's, but we still have to add their coefficients. So take -2 and add 5, and that, of course, will give you 3 for your exponent. Okay, so that was our m's. Okay, let's do our a's in blue. Okay, so since they both have a coefficient of 1, we just take 1 times 1, which is 1, of course, so we have an a. And then 9 plus 17 would give us 26. Okay, so 26 for your a's exponent. So your final solution, 56m cubed, a to the 26th. Okay, so remember today, you just have to add exponents that have the same base, and you multiply the coefficients that have the same base. Okay, see you later.